Nitrogen is crucial for life to exist on Earth, and although our atmosphere contains upwards of 78% nitrogen, in this form it cannot be used by plants or animals. This elemental form of nitrogen is very stable and has a very strong triple covalent bond, which requires a vast amount of energy to break. We need nitrogen to produce protein and DNA. So without nitrogen, we wouldn't have life as we know it on Earth. In nature, 90% of this nitrogen becomes bioavailable through fixation. Here, bacteria play the hero, converting atmospheric nitrogen into ammonia, which is a form plants can use. The bacteria that fix nitrogen are called diazotrophs. Nitrogen gas diffuses into the soil. Bacteria converts this form of nitrogen into ammonia. This is either taken up by plants through assimilation or further converted by bacteria into nitrates through nitrification. Nitrates are also taken up by plants. Plants convert these forms of nitrogen into organic molecules such as amino acids. Plants are then either eaten or die. When eaten by a consumer, the nitrogen-containing organic molecules are ingested. When plants and consumers die, microorganisms recycle the nitrogen, which eventually re-enters the atmosphere through denitrification. An example of the nitrogen cycle interacting with the carbon cycle occurs during this decomposition process. As the organic carbon decays, the nitrogen becomes available to plants. With a warming climate, as the soil warms, soil microbe activity increases, increasing the rate of decay. This increase in decay, coupled with an increase in carbon dioxide, another essential element for plant growth, creates a short-term positive feedback loop. An increase in nitrogen uptake, creating more biomass, which creates a greater mass to decompose. An equilibrium will occur as nitrogen is diminished through the leaching, biomass removal or cooling of the soil. Legumes are plants in the pea family and grow nodules on their roots for a particular bacteria called rhizobia to colonize. Here is a close-up of the roots of a legume. The bacteria and plant form a symbiotic relationship where the plant exchanges organic molecules such as sugars that the bacteria then use in the process of converting nitrogen gas into ammonia that the plant uses to make chlorophyll and amino acids. Bacteria use an enzyme called nitrogenase for the conversion of atmospheric nitrogen to ammonia, which the plant then assimilates. Farmers make use of this process by growing legumes for the purpose of providing nitrogen to their crops, saving money on synthetic fertilizers. Here we have an example of farmers interplanting a crop with legumes, in this case maize, a heavy nitrogen feeder. The maize plant takes advantage of any excess nitrogen produced by the legume, and when the legume has completed its life cycle, the maize roots ensure nitrogen is not lost from the soil profile. Compared to monocropping and depending on the legume chosen, this practice can increase yields of over 100%. Here we see the major fluxes of nitrogen through the cycle, plus the major reservoir sources and sinks. A non-biological method of fixation includes lightning, which creates enough energy to separate the strong covalent bond. The free nitrogen atoms then combine with oxygen to form nitrogen oxide. The nitrogen oxide dissolves in water, forming nitric acid, then falling to earth as nitrates, another form plants can use. You may have noticed that your grass becomes much greener after a lightning storm. Another important non-biological form of fixation requires human intervention. This process was discovered in the early 20th century when scientists discovered that an electric arc can be used to fix nitrogen, basically replicating the natural process of lightning. Today, the main industrial method is called the haber-bosch process. In this method, nitrogen and hydrogen are combined under high pressure and using iron as a catalyst, heated to up to 650 degrees Celsius. Now, industrial fixation equals all natural fixation combined. The ocean is a reservoir and it acts like its own nitrogen cycle. Nitrogen gas dissolves into the surface of the ocean and, like terrestrial plants, this nitrogen is not available. It needs to be converted by marine bacteria to an available form.